So, I'm starting another video holding a suspension shock again. The reason I'm holding this, I just wanted to kind of go through some of the stuff that we'll be leveraging. So we're going to be using some computer-aided design software, but also something that I don't think people have seen before is maybe some simulation software. So when I was talking about everything being very data-driven, that's essentially what I'm talking about. But just as a bit of an experiment, I'm going to be designing some bits for the suspension strut later. So I thought I'd video that. We're going to be making some linear potentiometer mounts, and I'll go through why we're making those and why that's really important to what we're doing in relation to the simulation software later on in the video. So let's stick that down and talk about the plans for the car. As I said, we're actually going to stick loads of electronics in the car. Obviously it's a relatively cheap car, but we're sticking a hell of a lot of electronics in and spending quite a lot of money on this. This is all starting with Fury X ECU, very, very capable ECU, absolutely perfect to run a V6. And one of the reasons for going with Link is there's a couple of guys out there at the moment who are doing some great stuff with the Link and the VR4 engines for the Glant and Legnum guys. So there's some knowledge there in that with VR4 engines. So it's always great to have support network, right? So that's one of the reasons we're going for the Link Fury X. This also talks really nicely. So Link talk really nicely to AIM. And AIM is the brand we're using for the PDM, so Power Distribution Module. But before I talk about the PDM, just a little bit more on what we're trying to do with that. So you heard me talking about it's going to speak really nicely to it. So if you've ever been behind a dash or in the engine bay of the FTO, you know there's wires absolutely everywhere. It works on one signal has a wire each, essentially. So if you want 10 signals, you need 10 wires. Things have moved on slightly in the communication world. We have bus communication now, so we're going to be using CAN bus communication from our Link ECU to our PDM, from our PDM to a couple of other things, as well as our dash, and we might be swapping out quite a few sensors to go kind of down the CAN route. It's going to massively simplify wiring, and rather than having 10 wires for 10 signals, we can potentially have kind of 2 wires for 100 signals. That might be a little bit extreme, but you get the idea. Along with that, all the signals, we also have to think about power. There's quite a lot of relays and electromechanical relays and fuses and things like that. In the FTO, we've got a fuse box down in the driver's side footwell as well as the engine bay. They're going to get mainly replaced, definitely the engine fuse box and relay. That's all going to get replaced with this PDM, this power distribution module. So this is a solid state relay, essentially. So I can power most things off of this, which is amazing. But the other amazing thing is this talks to my Link ECU. It can also talk to my dash, and I can feed all the sensors in it, and it can work as a data logger. So actually it's a really, really cool bit of kit that's going to simplify wiring, give us a lot of data, and essentially talk to everything really nicely and power everything really nicely. So really looking forward to installing that. To go along with that, and to make an old car work with something like a PDM, we do have to get a couple other things. So we have what AIM call their Rio, which is a remote input, I think remote input output device maybe. Essentially all of the stuff on the stalk, so indicators, lights, stuff like that, any push button things on the steering column, that can then now get connected to this Rio, which then talks via CAN to our PDM. But rather than using up one of the PDM slots, one of the CAN slots on the PDM, we get this little guy, a data hub. So this has got 4 CAN inputs, converts those 4 CAN inputs into 1 CAN input. So one of the dedicated CAN inputs on the PDM is the ECU. The other one we're going to have is a data hub. We're going to have a Rio into the data hub. We've got a GPS speed sensor into the data hub, and we're also going to have our channel expansion into the data hub. And you heard me talking about our linear potentiometers that are going to go on our suspension struts. That is what is plugging into these 4 channels. So this is essentially an analog to CAN conversion device. So we're going to set up our linear potentiometer sensors on the AIM software we're going to plug them into here. That's going to then plug into our data hub, which is going to plug into our PDM. The last thing we're going to have, which maybe not be needed, but you might not be able to see what this is essentially a CAN button keypad. So anything that I can't control through the Rio, if I need to pass things like MOT, I think that's going to come in really handy, and you can do quite fun stuff with the CAN keypad. Obviously that all then talks to our dash. Here we go, we've got our 3D printed converter, so it's going to drop straight into the FTO dash. A little bit more on that later. So that's all going to be sending signals up to our AIM dash. There is going to be a little interim step in that. We're going to need to just run things like the tacho fuel level and the engine temperature into the PDM on analog input, and then wire that into the AIM via its special lead, just so we can get things working, because I don't want to have to wait to install all this stuff until I get my ECU in, which is obviously quite a big leap. So one of the points of the car is to take things in stages. So the stage we're going to go to first is we're going to wire in the PDM, but it's essentially going to be our data logger, and it's going to run our dash. For it to do that, we don't need a lot of stuff going in here. All we really need is for this to power on, it to get a speed sensor from the tacho, fuel gauge sensor for the level of the fuel, and the engine temperature sensor. So that's all we're going to be wiring into that. We might also stick the oil pressure into here, the one that goes to the dash. That will then power our dash along with our GPS speedo, and that will give us everything we need to essentially drive the car. We won't have notifications on things like indicators and everything else like that, but I think that's going to be enough to drive the car to start with. Other plans for the car. You will remember I had said I built one of these before, so I've still got the VR4 engine for that. So FTO usually comes with 1.8, more commonly a 2 litre V6 though. That tops out about 200 brake horsepower, but not a lot of torque. It's very revvy, very kind of Japanese engine. In the larger cars, the VR4 Galant and Legnum, those came with a 2.5 litre twin turbo. So with a remap and a couple of simple mods, they're good for about 315 to 330 brake horsepower, but also 350 to 375 foot-pounds of torque. So that completely transforms the car and makes it a hell of a lot of fun to drive. Putting the power down then gets a little bit interesting. I don't have the Cusco plate diff that I used to have in my old car, which is amazing, and I regret selling it, but it's gone to a good home. I do have the version R helical torsion style diff, so that's just going to have to do for the moment until I might make the decision to go down the plate diff route again. We've also got the suspension you've seen. We'll be doing things like a roll cage. We might look at things like wide body, just with arches to start with. I've got a big brake kit to go on it, so I've got AP6 pots with 330mm rotors to go on it. And I think that's about it. But as I said, I want to do this in stages. So yes, the suspension is going to go on it. I'm still a little shaky about the brakes that the car has, as we're on the single pot GR calipers. So I might kind of not do that in stages and go straight to the AP6 pots. But things like a roll cage, so I don't want to take the car off the road for a couple of months while I install a roll cage. So I'm going to go harness bar first. I am going to put in bucket seats to sort out the driving position for me, because I am quite tall, and being in that first track day reminded me of how much I don't fit in an FTO with a helmet on. We're not going to drop in the VR4 engine straight away, and we're not going to drop in the ECU straight away. So we're going to try and do things in stages. So hopefully that outlines the plans for the car. The stuff I'll be leveraging, which is essentially CAD CAM simulation software with regarding design of parts, but also more excitingly simulation software to do with driving the car and car setup. So that's hopefully going to be really interesting, because with all the sensors that we're going to put in the car, the suspension potentiometers on each corner, steering angle sensor, speed sensor, wheel speed sensors, I think that's it for the moment. So the basics we need to run that simulation package, hopefully that's going to give us all the data to make really good decisions around the car, which is what I was talking about in that first video. So hopefully that outlines, as I said, the plans for the car. Let's have a little look at CAD and some 3D scanning and what we've been up to. And I have been starting a couple of little projects, but I haven't finished them yet. So I'll give a couple of snippets of that, which I'll hopefully, when I finish, I'll make some new videos. Tap tap for the CAD, hey? So we are back in the FTO, and we haven't actually done a lot for a while, and you can probably tell that, hence the big fat jumper, and it's no longer summer. But what we have been doing, so digital dash, that needs to go in. We've got to mount it first before we sort of think about wiring it up, or they kind of happen at the same time. So I got some prototype parts, had to print a custom holder for the 10-inch dash in 2 sections, 3D printed. Once it's working and all fitting, then we'll get it printed properly in one piece. But just my printer's not quite big enough to print this in one piece at the moment, so we're in 2 pieces and we're seeing how it fits. So that's in, a couple of bottom screws in, it's all fitting nicely at the top. Might have a slight issue with how high these are going to be. So this is the road dash, so we've got road signals because it is still going to be driven on the road MOT car, even though mainly used for track days. The thing I'm worried about is now sticking this in and seeing where this goes. So let's have a look what that does. So we're starting another new project without actually finishing the other ones, but as I said, need to sort out the driving position because actually in the first one it was really compromised. So we are getting rid of the FTO seat and changing in a nice big race tech seat. Also just weighed them with brackets, just over 10 kilos, as is just under 18, so decent weight saving. I fit in it, hopefully it will be able to get me lower, and it just looks cooler, doesn't it? Here we go. So if we're going to be designing bits for it, we've got to get this apart. So we take off the little adjuster at the top, take off the top nut. I've already undone the spring seat down there, so there's no tension in the spring. Take off that top nut. Bit more thread on it than I thought. Top mount off, spring off. So we're essentially just left with our damper. Okay, so the reason we want all this apart is we want, if I drop that back on just to show you, when this is going up and down, when that is going up and down, we want to know exactly what is happening with this. But we also want to know how fast it's happening. So if we've got a linear potentiometer, that's essentially just measuring the distance between 2 points. But given that we know time and distance, we can then work out speed. And that's really important when we're looking at tuning our dampers and doing some other bits and seeing if these dampers are actually right for the car. I saw someone else who's actually done custom dampers, making very similar point. I think the rear FTO dampers are probably more likely Evo dampers, and I think they're probably more suited to an Evo and the weight distribution than an Evo. But we'll come on to that, and hopefully we'll be able to verify that or kind of prove it wrong or right when we get some data. So the idea of this is where the spring seats on the top mount, where the spring seats at the bottom mount, we're just going to make basically a collar that's going to come off that with a little mount on it. I had originally looked into redesigning a threaded collar, which is what the Öhlins shock has, and they have kind of less of these little ridges, but where they've got these large bits, they have a little threaded hole. I think that's what that is. Haven't actually ever had Öhlins shocks in front of me which have that, but I think there's a little threaded hole there. But also looking at other solutions, a lot of people just go with kind of like a collar that sits on here, that the linear potentiometer mounts to top and bottom. So that's essentially what we're going to be designing today. So we just need to take some slices of that. First thing we need to do is, it would be easy to get this on if it had a little gap in it. So that looks like 12.5 mil. Just zero that again, make 100% sure. Yeah, 12.5 mil. Could be 1/4 inch, but we're not too worried about that. So we've got 12.5 mil, and importantly here we have 59, and then the spring, we use to measure the spring down there, because we need this to be on the outside of the spring, is about 90. Perfect. Okay. So let's jump on the CAD and make something.
So here we go, here's Fusion. So this is our CAD program. This is also what we're designing in Fusion at the moment, which I'll talk about a little bit in another part of the video. Just to show you where this has come from. This has come from a 3D scan of the FTO driver's side footwell. I'm not actually going to go with this design of seat brackets. I'm going to change the design slightly, but you can see how I've used the 3D scan, picked up the mounting point on it to then make essentially seat brackets. So that's the sort of thing we'll be doing, but just as a more simple part. Let's flick over to this. So we decided our collars were 59 mil, and the outside of the collars were a little bit wider than that. Let's grab the calipers and just double check. I think we got these off the, I think we said 90. They're about 85, and then the springs are 90, so we want the outside of these about 85. We are going to cut a little bit out of this. So you can choose center point arc. So we're going to cut chunk out of this, and we want the smallest part of that chunk. Let's create a point then. Smallest part of that chunk to be, we said 12.5, didn't we? So we've actually got loads of room there, so let's make it 20 mil so it fits on nice and easily. We can then extrude those 3 mil, and we're going to use our fillet tool to round these out. I'll just repeat that step for those. Perfect. And then on the other side of that, let's actually do this in the original sketch, because I want to, just one of those people who likes everything to look nice. There we go. So in the original sketch, what we're going to do is pick up the center point between those 2 points there, and then extend that line through there, and just make sure those are collinear. Oh, they're already parallel, so that's fine. We will make these into construction lines so they don't play anything on the sketch, and then from there we're going to create a slot, center to center slots. Let's go 12.5 wide, but we did actually want at least the outside lines of that to be proper lines. And we'll redefine that to include that part. There you go. If we go and edit this again, we can also just do a circle on the end of here. Bring that forward so everything rounds off nicely. We're also going to round off these bits in here. that's going to be our collar. So we're going to have a little rose jointed mounting point on here for our linear potentiometers. Interestingly, we're not going to use the AIM ones because they're a little bit expensive, but we are going to have a look at getting a couple of these cut. But what we're going to do first, I do have prototyping means at work. I'm really lucky, so I might prototype these before getting them laser cut in something maybe stainless, probably alley. So we'll see. So let me know if you do enjoy the CAD side of things. I know it's not everyone's cup of tea, but let's also get on with showing you a little bit of work that we did on the FTO earlier.
So that does wrap up the video. Let me know what you think. We're still kind of working out what we're going to show you. Do you like the talking about the electronic stuff and all the theory behind that? Are you interested more in the simulation software? Do you want to see us design more stuff on the CAD, or you want to see us working on the car? Let us know. Any feedback, really appreciated. Cheers.